And a lot of these conditions are lifelong, and some of them are life-limiting. The condition is rare, it's not known, we can't test for it, and we don't know. I mean, you know, it's all those unknown unknowns. So that's why we need other ways that we can look to see that we haven't missed or don't need to consider a genetic cause for the problem. Probably quite a number of members of SWAN were diagnosed after the introduction of the microarray chromosome test, which then detected small chromosome alterations that had not previously been detected.
Our genetic code, you'll know, is written in a language called DNA. And it's a language which, rather than 26 letters and a bunch of punctuation, just has 4 letters, A, T, G and C. The equivalent of chromosome testing, I guess, is standing in the doorway to the library and saying, well, let's just take a bit of a look around. Can I, without jumping to any conclusions, can I spot whether the problem, where the genetic alteration that's the cause of this condition lies?
For the NHS to sequence 100,000 patients, and those are split up into 3 different areas: those with cancer, those with rare diseases and those with infectious diseases. So essentially at the end of the 5-year tranche, the idea is that 30,000 patients with a rare disease for which the underlying genetic cause is unknown will have been recruited.
Better screening, and by better screening we'll be able to identify the sort of disorders that we look at. We'll be able to identify them earlier. By identifying them earlier, we have the opportunity to treat them early, and by treating them early we have a better opportunity to either alleviate the symptoms or prevent the symptoms from starting in the first place.
Decisions we made in life for the next 10, 15, 20 years, some of the bucket list things we had may be different, or a different change of direction compared to if we had a diagnosis of what we knew with Alicia, and it may change our kind of family life altogether.